So welcome to this lecture of computer system architecture. In this lecture we will discuss two architecture designs of microprocessors, that is complex instruction set computers and reduced instruction set computers. So let us first begin with a brief overview of the working of a microprocessor. So a microprocessor, or simply that is known as a processor, is basically a logic circuitry that can respond to the processes, and it can perform basic instructions that drive a computer. Okay, and what happens that these instructions are basically stored in our primary memory. So from the primary memory the processor will read the instructions and then it will execute them. Now along with that, every processor architecture supports an instruction set. So an instruction set is basically a set of instructions or a program that can used to perform operations on our machines. Okay, and these instruction sets, they are generally specific to a CPU architecture. So depending upon the CPU architecture we will have a corresponding instruction set, but there are few instructions that are common to all the architecture, like your read instruction from the memory, or decode instruction, execute instruction, and write back instructions. So these are some of the commonly used instructions that are available in most of the computer system architecture. Now from the architecture point of view, the microprocessor design can be classified into two categories. The first one is the complex instruction set computer. In short, this is known as CISC, and the other is reduced instruction set computer, and which is known as RISC. Okay, so what is the fundamental difference between these two architecture? So the fundamental difference lies between the complexity and the number of instructions. So in case of a complex instruction set computer, that is CISC, it consists of very large number of instructions, and that is why it is known as complex instruction set computer. On the other hand, in case of RISC architecture, so such microprocessor utilizes a very small and highly optimized set of instructions, and using these instructions we could further write our more complex instructions. So overall the complexity and the number of instructions are very less in case of RISC architecture. So that is why it is known as reduced instruction set computers. So let us see first a brief history of our CISC microprocessors. So initially most of the microprocessors were designed using the CISC architecture because the memory was expensive in the early days, and using a CISC architecture it was easy for the designer to save memory, because a CISC architecture can directly read the instructions from the memory and can fed into the processor. Okay, along with it, the CISC based architecture, they help designing a compiler task much simpler, and because what happens that using a CISC architecture, most of the burden of generating the machine instruction was given to the processor, and the compilers could be designed in a much simpler way. Okay, so for example, suppose that we need to perform a square root operation. Okay, so in order to save writing a complex compiler, all the burden is given to a CISC processor, and this CISC processors have the complex instructions which have the ability to do such kind of complex operation, like calculating the square root or performing any logarithmic operations and so on. So let us see what are the characteristics of the CISC computer. So the first characteristic is that the CISC instructions can be thought of many different types of instructions that are bundled in a simple instructions. So basically a CISC instruction is much complex, and one CISC instruction we can assume that it internally contains a combination of different types of instructions. Okay, then the second characteristic is that most of the CISC based processors they consist of large number of instructions. For example, these instructions could range from 100 to 250 instructions. Thirdly, these instructions they generally perform some kind of specialized task, and such specialized tasks are, since we know that they will be used very infrequently, so the instructions corresponding to them they are used very rarely. Along with it, the CISC architecture supports a large number of addressing modes. So there could be possibly 5 to 20 different addressing modes that are available in CISC architectures. And we have variable length instruction formats. So again, this makes the architecture complex, and the instructions has the ability to manipulate operands directly into the memory. So there is no need to load the operands into the registers of the CPU. We can directly manipulate them into the memory. So that is the last characteristic. Coming to the advantages of CISC architecture. So since CISC architecture is microprogramming based, so we can write our instructions which are closely related to like our assembly language, and that is why they are much less expensive than that hardware based control units, which we will see later on in case of RISC processor. Okay, then secondly, since each instructions becomes more capable, so very few instructions are required to perform a difficult task. Okay, so that will help us to make efficient use of a relatively slow memory which was earlier present in the processors. And since these microprogram instructions can be written to match high level constructs of high level languages, so the compiler designing task, that was again the complexity of that compiler design task was reduced. So these are the advantages. Then coming to the disadvantages. So as we know that CISC architecture consists of very complex instructions, and most of these instructions are very rarely used by the programmers or by the compilers. Then the memory references and any kind of load and store operations that are relatively quite slow, and this overall reduces the performance of our computer system. Thirdly, that these procedures and function calls, they generally take a large amount of time, and thus they hamper the performance, or we can say that is a major bottleneck in case of CISC architecture. And the instruction set of and the chip of new generation hardware, they have become more complex, so that is again a disadvantage in terms of complexity. Now let us switch over to the RISC architecture. So first of all, let us see a brief history of RISC. So this RISC architecture based processor, they started coming in the 1970s. This is because during that period of time the memory size has increased and the overall cost of the computers has gone down. Okay, along with it, the compilers have started to becoming more advanced, and that is why in the 1970s IBM was the first one to start producing the RISC based processors. And later on in 1980, David Peterson, he was a computer science scientist, and he began the first project that gave a boost to this RISC based approach. So the characteristics of RISC, so these characteristics are exactly opposite to what we have seen in case of CISC based architecture. So in case of RISC, we have relatively few instructions and very few addressing modes, so that is why the complexity is less. And the memory access is performed by using the load and store type of instructions. So we have to load the operands into the registers, and then we have to again store back into the memory. So these load and store operations are frequently used, and all these operations are done within the registers of the CPU. So we have to first load the data into the registers, and then only we can perform the operations. So we cannot directly access the memory just like in the CISC architecture. Okay, next is that the instruction format are of fixed length. So again the complexity is reduced since we have all the instructions of fixed size. And other thing is that only a single cycle is required to perform an instruction. Okay, so as compared to CISC architecture, which could take multiple cycles to perform an instruction, so here all the instructions are quite easy, and that is why they could be performed in a single cycle. Next is that the architecture is hardwired rather than microprogrammed, as we have seen in case of CISC architecture. And along with it, we have to require a large number of registers in the CPU, because everything has to be loaded into the registers before the processing could be done. And finally, it make use of an efficient instruction pipeline. So the overall speed up using the pipeline is more. Then the advantages of RISC. So the RISC-based architecture, they have more speed, approximately 2 to 4 times faster than the CISC-based processors. The hardware is much simpler as compared to the RISC processor, because the instructions are relatively low, so the hardware is also simpler. And shorter design cycle, that the RISC processors, they have a very they could be designed very quickly, and they can complete their work in 1 clock per cycle. Okay, so that is why they have a shorter design cycle. Then there are few disadvantages as well, like the first one is the code quality. So code quality means that it is the responsibility of the programmer to write the instructions in a optimized way. If the instructions are not optimized, they are not written very efficiently, then what it would result? It would result in a large amount of waiting time for the result of one instruction to be processed before we can execute the next instruction. So we need to have a good quality of code that could be run efficiently on RISC-based processor. Then the second is your code expansion. So as we know that in case of CISC-based processor, they consist of complex instructions within a single instruction. But in case of RISC processor, reduced instruction set computers, the machine require multiple instructions for doing the same task. So that is why the code expansion is more. And finally, the system design. So that is again another problem that is faced by most of the RISC-based machines, that they require very fast memory, because we need to have to load everything from the memory into the registers. Okay, so if the memory is slow, then this transfer of data from memory to registers will take a lot of time. So that is why we need to have a very fast memory along with large memory caches. So cache memory should be high so that we can quickly load and store the data from the cache memory into the registers. So that is the third disadvantage. So finally, let us see an example to understand the working of CISC and RISC-based processor. So let us take an example of multiplying two numbers in a memory. So suppose our memory is divided into these blocks. Say it contains six rows, and it contains 4 columns. Okay. And secondly, we have this execution unit. So execution unit is responsible for doing all the calculations like your addition, subtraction, multiplication, and so on. And along with it, suppose our CPU contains these registers, say 6 registers are present. So we can load the data from the memory into the registers, and then the execution unit can execute the operation. So this is the architecture of our computer systems. Okay, so let us see an example where we need to multiply two numbers. The first number, say x, so this number is stored in location say 2, 3, that is second row and third column, and we have another number y that is stored in the location 5, 2, that is at fifth row and second column. So what we want to do, we need to multiply x and y together and store the result again at the location where x is stored. That is we want to store the result again back to this location, that is second row and third column. Okay, so let us see how this multiplication will be performed in RISC and CISC-based system. So in CISC-based approach, since we know that it consists of complex instructions, so one of the instruction is multiply instruction. So using this single complex instruction, we could multiply x and y together and store the result back to the location of x. So this operation means that we are multiplying x equal to x into y. So basically we are trying to perform this operation, that both x and y are multiplied together, and the result is again stored back to the x location of the x itself. So you can see that in case of CISC-based approach, we need a single instruction to multiply two numbers. However, in case of RISC-based approach, these instructions are divided into load and store type of instructions. So first of all, we need to load the value of x in register R1. So basically what we are doing register R1 equal to x. Then in the second step, we need to load the value of y into register R2. So basically it means R2 equal to y. Then we need to do the product. So next instruction is of product. R1 R2. So this means that R1 equal to R1 into R2, and finally we will store the result back to the location of X. So we will store X equal to R1. So you can see that in case of RISC based approach, since it has very simpler instructions like load, store, product and so on, so we need to individually load each of the operand into the registers first. After that we will perform the multiplication within the registers, and finally the result is stored back into the memory. So in this manner the RISC contains it contains more number of steps in order to perform the same operation of multiplication. Okay, so this is about the lecture. I hope the difference is clear. Finally, let us see the difference between CISC and RISC based computers once again. So the CISC based design, it is more hardware oriented. The focus is given on the hardware, while in case of RISC architecture it is more software oriented, so the main focus is given to the compiler design. Then secondly, in case of RISC, the instruction size is mostly varied. We have different sizes of instruction, maybe a 1 byte, 2 byte, 4 byte and so on, while in case of RISC the instruction are always of same size. Okay, so we generally fix, or we generally set the size of the instruction that all the instructions, say it will be of 2 bytes only. Then the third one is that the addressing modes are complex as compared to RISC based architecture. So RISC, in that case we have a very simple addressing modes, and in case of CISC the memory to memory operations could be performed. Okay, while in case of RISC architecture we need to perform register to registers operations. So first of all we need to bring the data into registers, and then the operations are performed. CISC based instruction, they are mostly they are slow because they require more than one cycle to perform an instruction, while in case of RISC the instruction execution is fast because it requires only one instruction cycle. And finally the main objective is less code in case of CISC based architecture, while the main objective is speed in case of RISC based microprocessor. Okay, so this is about the lecture. I hope everybody is able to understand the difference between CISC and RISC architecture. Thank you.